Good morning, good afternoon, everybody. Thanks so much for joining this last episode of 2022 of Learn with Nick, with Mehran today joining us to talk about software attack surface and how to understand it, how to reduce it to make sure that you bring more performance and security to your software capabilities. So this is going to be a very interesting episode. Before we get started, I wanted to remind everybody that we want to be independent from big tech, and we want to build our independent mailing list so we don't have to rely on LinkedIn and other social media platforms to reach out to you. So if you have not done so already, please go to inthenickoftime.tv to get registered to our mailing list so we can send you one email a week to tell you about the next episode coming up and the videos we released every week on deep dive on technology. Additionally, if you've not seen it yet, learnwithnick.com is up and running. Check it out. We have a 50% off for military, civilians, and veterans, and 20% off for early adopters ending this year with Let's Beat China coupon code. So check that out. The last video we posted is on what is RegOps, regulation operation. So check that out if you have not seen what we can do with RegOps and how that can remove the bottlenecks of your compliance and regulation security. Check that out and give us some feedback on that video. The next video coming up is going to be on GPT, so you'll see that coming. And next, we're going to have another video on the supply chain security and how to harden bits of software. So it's going to be also very interesting. So stay tuned this year for these two videos coming up this week and next week. With that, if you missed the one before, we had the WebAssembly video that came out last week showing the benefits and the value of WebAssembly and how to bring native C, C++, Rust, and other languages into the browser. So check that out. Very interesting for performance, of course, reasons. Pretty mind-boggling also what you can do now with containers. Teams like Istio are starting to use it in Envoy for the reverse proxy to be able to bring capabilities on top of the proxy. So check that out with WebAssembly. And if you've not seen it yet and you want to maybe do a late Christmas gift, we have the store.internetofTime.tv. All profit, 100% of the profits go to the Fisher House Foundation for this quarter. So please help us give them a lot of money. You'll find a few cute t-shirts that are pretty fun and will make people laugh. So please go check it out and let us know what you think. If you have ideas of new t-shirts and designs for next quarter, let us know so we can get those ready for next year. Just reach out to us on LinkedIn. If you've not seen it, we have the Cloud Native Town now on cloudnative.town. So go check that out. Completely free. Anyone can go and have events. We have a lot of different rooms about different topics. If you have content, if you have videos you want to share on there, we just published a video that will be pretty interesting for people looking at Istio from 0 to 60 in 2.5 hours. So for a very good deep dive on the service mesh. We have more videos coming also on HPC and other technologies. So if you have content you want to share with us, please send it to us and we'll put it on the metaverse. A lot of telco banks, 7 nations using it now. We do a lot of events. If you want to organize an event completely free, let us know, reach out to us, and we'll be able to help you do that. All right, with that, we have a pretty amazing guest today. Mehran is joining us today. I'm going to give you a quick rundown of his bio before we bring him up on the screen and directly let him do a better job to tell us about his journey. But before we do that, I wanted to give you a quick rundown. He's a CEO of RapidFort. It's the first software attack surface management platform in the market. Obviously, he has a very deep background in security and distributed systems and cloud computing. Him and his co-founders saw the opportunity to automate all the remediation that is really part of the operating open source software vulnerabilities. And what is done, of course, with RapidFort is pretty mind-boggling when it comes to identifying and reducing the software attack surface and managing that and getting a better understanding of what's going on. So you'll see that today. Before his time at RapidFort, he founded Percipo, building the fastest and most accurate AI tech for describing human images using machine learning techniques. So very deep dive and deep expertise also in AI and machine learning, obviously. Before that, he ran the EFI's core business unit and helped make it a very large name of in digital imaging. And of course, he's an entrepreneur, as you can understand. He's based in San Francisco, despite kind of the rampant nonsense going on in terms of homelessness and stuff. But that's what it is. And you enjoy, of course, programming and building simple products from complex technologies. Who doesn't, right? How to make things simple, how to make it something that can be understood and used at scale, and streamlining the adoption of very complex technology is probably the best way to innovate and bring tangible value to the world. So with that, very excited to have Mehran with us, bringing up on the screen. Welcome.
Hi, Nick. Great to be here. Thanks so much for having me.
Yeah, so excited to have you. Obviously, you bring a breadth of expertise both in machine learning and, of course, with the work you've done in understanding and imagery. That's obviously something that the Department of Defense would very much enjoy having better capabilities of detection. And of course, now with what you've been doing as part of the software attack surface management. And we'll talk about that today. I think people are going to realize kind of the complexity of having to manage and understand what's going on in your software supply chain and your software ecosystem as a whole. But before we get started, and I have a lot of questions for you. And by the way, people, if you have questions, make sure you start asking the questions in the comment section below. We have already a lot of questions already from social media, so we should be pretty good. But do start asking now if you want to have a chance to get your answer before the end of the show. With that, we'll give you the chance to give us a quick rundown of your journey before we start a deep dive into the software attack surface.
Sure. Where do I start? Well, I was born in Iran. I finished born and raised. I finished high school there, and then I immigrated to Canada. I lived in Montreal. I went to Cégep there. It's a sort of a college in Quebec educational system. And then I ended up going to University of Waterloo. I studied math and computer science there, and then I did my master's degree in system design engineering. I worked with what was Bell Northern Research back then, and that was the R&D arm of Bell Canada. It became Northern Telecom, and then I started working for. After my studies, I started working for a company that was a spin-off of Bell Canada called World Links Telecommunications. We were building software for doing what we do today here, sharing multimedia, application sharing, videos, and so on and so forth at the time. And so I lived in Toronto, in Vancouver, and then I moved to Switzerland for a while. I lived there and worked with my brother, working on statistical models for predicting swings in stocks, and being able to sort of weed out the market factors out of these stocks, just to identify cyclical stocks and so on and so forth. And so that was that. And then I moved to the US, where my family lived. My parents and my sister lived, and I ended up working at a company called Electronics for Imaging. I did try a couple of times doing other entrepreneurial stuff. One of them was just right before 2001. And in 2000, we started working on building basically this big iron boxes to support high quality, and at that time DVD quality video. 50,000 streams coming out of a single box, and so on and so forth. And I remember that I went down to Los Angeles for a trade show that involved a lot of these, media producers, HBO and Disney and whatnot. And that was September 11, 2001. So that was the end of that effort. And as you mentioned, I started a computer vision company in 2008. Well, beginning of 2008. And we demoed a whole bunch of our ideas in August of 2008 to a number of investors, and they were very interested. And then, of course, there was September of 2008, and then after that, things went quiet in the venture and funding landscape for quite a few years. But we kept on going, and 2008 was sort of like the year where there was a lot of new things. There were iPhone was new, and the cloud was new, AWS was new, high resolution flat screens were new. There was a lot of new stuff happening there around that time frame, and we were bringing a lot of these technologies together to build unique products. But one of the things that sort of we identified was that the computer vision as a field was moving from the realm of image processing and edge detection and filters and so on and so forth into the realm of machine learning. And we got really interested in that space. Specifically the space that we got interested in was not so much around face recognition, but we call it face description, understanding human images, understanding demographics, mood, whether they wear a hat or glasses, or if they have a beard or a mustache, and those kind of, if they're happy and so on. We focused on a lot of research over the next 2 or 3 years into 2011 in trying to take these algorithms. And the idea that we had was that the reason that these algorithms can't solve some of these more complicated vision problems was because we couldn't train them on large data sets. And back then in 2007, 8, you could only train them on, I don't know, 6, 7, 8,000 pieces of data. And so we wrote a lot of those algorithms to be able to train them on 500,000, eventually about 1 million pieces of visual data. And so we made these systems that were quite accurate, and we started OEMing that IP into people who built solutions for physical retail. That was anonymous human analytics. We could detect demographics from video feeds on fairly low-powered machine without any GPUs or anything. With a lot of accuracy. And we ended up installing in some 40 to 50,000, 45,000 different retail locations until I got focused into the cybersecurity space a few years ago. And then, of course, COVID came, and a lot of that stuff around physical retail and what people are doing in shopping malls and stores came to a halt for quite a couple of years. But nevertheless, we started working on RapidFort with my co-founder Rajiv, and the idea there was that there was a lot of change in the way that we build software and we deliver software, and along with that came a number of security issues, and we were just at the beginning of the industry understanding what those issues are and to be able to solve them. And so that's how RapidFort came about. And what my journey was from sort of doing networking to multimedia communications to imaging to computer vision, and now cyber security.
Yeah, that's amazing. That's quite the journey, and as also an immigrant, I can attest to the complexity of what you achieved. So that's pretty amazing. We're lucky to have you here. So obviously, we're going to dig into the real meat of the subject now and talk a little bit about software attack surface. But before we get into the real meat, tell us a little bit about what problems are you really trying to solve with RapidFort.
Right. I like how you refer to it, Nick, where you say, hey, how do you stay secure while you keep your development teams moving at the speed of relevance? And there's been quite a lot of change in the way that we build and develop software particularly over the past decade. And obviously it's been changing all the time very quickly, but there's been a dramatic sort of change in in the speed at which we sort of innovate, which comes primarily due to the prevalence of high quality open source components. I mean, you build your applications using a lot of open source components. 70 to 90% of the modern software is made up of open source, and that allows us to sort of innovate some 3 to 10 times faster. We don't have to write a lot of this code that we need to put our application logic on top of it from scratch. That's obviously a great thing, but it comes with this along with the fact and the set of problems that it brings with it, which is these aren't the developers that you pay, that they sit on your team. You can't call them up and say, hey, fix this issue, or I have that security issue, and why did you code this like this? They don't come from your vendors either. You don't pay them any money a lot of times. And so you have no control over, the fix cycles and the security issues and all that kind of stuff that comes along with it. And so how do you go about managing this? We're not going to go back and write every line of code ourselves. Open source has been really a huge benefit to the entire world and to the software industry in particular. And so how do you manage that? And the other part of it is obviously moving from this whole data center sort of waterfall methodology of managing software projects to the sort of cloud DevOps methodology, where we have multiples orders of magnitude in terms of improvements. We went from planning projects from 6 months, 9 months, 12 months ahead of time, however long the project would take, and we just go back to work and start coding and testing, and then 6 months, 9 months, 12 months later, we deliver a piece of software. Now we are delivering value to our businesses and to our customers on weekly, daily, hourly basis, dropping changes into production and getting that value straight out of engineering. The innovations are coming and going straight out into our business, literally in real time. And with all of that change, how do you sort of get your head around, managing the security issues that comes along with it? And what we started out with at the beginning with Rajiv was very much a shift left movement. We're like, okay, we're gonna take, and this came from a real problem that Rajiv had experienced when he was at Palo Alto Networks, where he worked on a really, really important project, rewriting a monolithic application to go from 4 billion hits a day to 50 billion hits a day. They worked on it for 9 months. Everything was ready to go, and security team comes and says, well, you have 5,000 vulnerabilities. We're not going to let you deploy this, and so and they were flabbergasted. They're like, what do you want me to do with the MySQL vulnerability? And so back and forth, stand up after stand up. 6 months later, everybody shook hands, and obviously there were some updates to packages, some a couple dozen of them were addressed, and there was newer vulnerabilities that came reported and so on. And what we realized was that, okay, well, this stuff could be probably better handled if the engineers knew ahead of time. And so our focus at the beginning was a lot around sort of bringing that visibility into the IDEs, into the developer workflows, where developers spend most of their time, and give them a heads up. So by the time they get to the tail end of the project, they have all the stuff that they can explain to the other teams as to why the project is where it is, and be able to sort of facilitate the communication across the teams from the left to right. What we saw at the time, this was over 3 years ago, Nick, when we started coding some of this stuff. Shift left was getting really busy. Everybody was talking shift left, shift left, and there's a company called Shift Left. I think they're still around, Shift Left, and we were looking for differentiation. We're like, hey, but there's all these companies who are doing a lot of really cool stuff in this space. How do we differentiate? And one of the things that, and we didn't have these numbers, we were just really early on in the journey. We're like, a lot of the software that we have in these applications is open source. We don't really understand what these components do. We have a very cursory idea of what each component that we pull onto our application does, but only at the API level. And each package that you pull into your application does 100 different things, and you only use a subset of those things. So what do we do with all the software that we pull into our application? And so we said, okay, for us to understand this, let's run this application and monitor it and see what it does. But let's build a system that allows us to do this in an automatic way. And so we set out to build what we call a very transparent instrumentation technology, so that you could run your applications, specifically working on containerized applications. You can run these containerized applications in what we call their natural runtime environment, without them knowing that they're instrumented, without other applications knowing that they're instrumented. You could run any number of instances of them and so on. So when we collect behavior on the back end about what these applications do when they're running, and maybe if you could surface this to the developer, that has a whole bunch of value, because that could be, as developers, we were interested to know ourselves. It took us a few months to get the first version of that instrumentation going. And when it started working, we realized that there was a lot of software that's not being touched in these workloads. There were a lot of files that they were never used, never opened, never started, never nothing, and so we were surprised by that, and then we started pulling workload after workload from Docker Hub, and we noticed that some 50 to 90, sometimes 95% of the software that was bundled in these applications is not being touched. And so that became an exciting thing for us. We're like, well, this is a really interesting finding. And so the next step was that, well, if we write about this, why don't we just sort of throw away all these files? Will it work? Of course, it didn't.
Well, yeah.
It didn't work at the beginning, and we tweaked this and we tweaked that, and we figured out the optimization bed of removing these components, and that started working. And so then we went out to the not to the world, but to our circle of people, including at some point you, Nick, back in, I think, a couple of years ago now, and
Yeah.
said, hey, this is what we found, this is what we're doing, and we got really positive feedback. I remember our first conversation with you, when we hung up. I think it was Russ or Rajesh said, "Did you hear what Nick said?" He said, "That's really impressive." And, and so,
That's
so,
not every day I say that. So
so that became the focus of the company, and obviously from we've evolved quite a bit over the past 2 years, on where that story was. But that's that's what we found out, that part of um, what we were doing, and what we're doing a lot more now than we did a few years ago, scanning all these components, understanding all these different parts of the software that we're bundling into our application, and saying, hey, these are all the known issues that we know. And that list is getting really, really large. When we go and look at mid-sized companies, we see that they're sitting on between 1 and 3 million open source vulnerabilities in their production infrastructure. Large companies are sitting on 10 to 20 million of them. And so what do you do about, how do you shift left 1 million vulnerabilities to developers? So what's the process to sort of, manage all of that? And of course, there are a lot of good companies that are trying to offer solutions for this. They connect it to, loose permissive permissions, for this bucket and all that kind of stuff. But at the end of the day, these are still holes in your software, even though if they're not connected to your loose permissions and so on. And you can't sort of pull a wool over your eye and say that the next state actor from North Korea is not going to figure out a way to exploit these things. Because you're going up against an adversary that's becoming ever more sophisticated. Cybercrime is a violence-less crime, and so it's starting to attract very educated people who have sort of borderline scruples that come in and for money, and I'm talking about
yeah.
just the criminals. If you want to separate that from nation state actors and so on and so forth. So these are some really, really sophisticated teams that you're going up against. And you have to have a broader view of how you manage the security around all of these components. And that's the problem that we're trying to solve. How do you do that while we deliver 100,000 changes into, I think Amazon delivers 100,000, 150,000 changes into their production environment on a daily basis. How do you stay secure? How do you get your arm around, all of these problems while you move at that pace? That, you're innovating really quick and you're delivering those innovations. And of course, we're just a very small piece of the whole picture, but I think that we're onto something that's important in the overall picture of things.
Yeah, I mean it's a small piece, but an important piece, I guess. And when you start looking at the problem, I guess you start with identifying the issue and getting to know what's inside of that software. So I guess walk us a little bit through how you manage to do that at scale and automate that process of discovery.
Sure. At the heart of it, obviously, is what has come to be known as an SBOM today. What are the actual components that my software is made up of? Let's start there. How did you build this software? What did you pull in to do it? What are the different kinds of packages and libraries and so on and so forth that you use to build this software? Because those ones are, at least I could correlate those to known set of issues that people are finding and reporting. And of course, there's your own software that has its own set of issues that hopefully running SaaS tools and cleaning it up and lint tools and all, and whatnot. But if 70 to 90% of your software is from somewhere else, it's really valuable to know what you use to build that software. And so that's the beginning of it. How do you figure out what are the components? And that's becoming standardized through the SBOM efforts, SPDX and Cyclone DX and all those kinds of things, which is a good thing. We're still at the really, really early parts of that journey. But people have, including us, people have figured out how to fairly reliably understand what your software is made up of. So let's create that sort of that bill of material and start there. And then the next thing for us is that, obviously, as I mentioned, but what do these components do? How do they interact with each other? What is their interdependencies? Not only at the build time, where dependencies are sort of statically defined. Package A needs packages B and C and D and E for it to be installed. But at runtime, do I need all of those packages to when I'm running? And so let's understand those things, and that's what we call sort of the, for lack of a better word, a real bill of material. This is what really is being used in your software, and then obviously for each one of those components, accurately identifying known vulnerabilities, reporting those vulnerabilities, and surfacing those to the people who are managing this software, and allowing them, giving them tools to sort of prioritize those. Of course, there's the CVSS scores and what comes out of MVD, and what comes out of the particular advisors in terms of severity and all that kind of stuff. That's very important. Another thing that we do, we use machine learning techniques to sort of predict what is the likelihood of does a particular vulnerability have a proof of concept? Having a proof of concept, for example, really increases the risk of a vulnerability, because as much as they're sophisticated cyber criminals, they're also lazy. They have limited times, the amount of time when they get into your infrastructure. They want to stay under the radar before they get detected and all that kind of stuff. And so what they want to exploit typically is what they have in their tool set, what they have, what's been weaponized. And that typically comes from a proof of concept of a vulnerability. And so once a POC is known, the risk of a vulnerability goes up quite a bit. So we report that, obviously, in our vulnerability reports, but we also have a model that predicts over the course of next 3 months what's the likelihood of a POC becoming published for this vulnerability. And that's based on basically the historical data that we've collected and trained the model on. And so we present that. It's kind of very much in line with some of the other stuff that's been done. Kenna Security has, obviously, the ESPP. So, yeah,
Yeah, either
yeah.
way.
And
Yeah.
they try to estimate the likelihood of an exploit, which is one step further. But I think that exploit is such a contextual sort of decision for you to make. Is it internet facing, or what kind of people have access to it, and so on and so forth. Um, Probably a more useful understanding of if a POC is going to be available gives you a better indication of where you want to put it on your radar. And so that's what we surface. And then obviously we surface all the metadata that a lot of these other companies also include in the reports. What are the links? What are the links to the exploits? How what's the kill chain and all that kind of stuff? We try to report on those. But the whole idea is that to package all of that information, give the users the tools to prioritize these things and go after them, because nobody's going to go and fix a million vulnerabilities, or research a million vulnerabilities, or even if it's 200,000 or whatever it is, highs and criticals in their infrastructures. They have to be able to prioritize it in some reasonable way. And we try to pull as much information as we can in some sort of a nice and easy to consume way, and allow people to slice and dice it and address those.
That's very
Um,
cool, and the acronym is EPSS, I guess. So thanks
EPSS.
to that YouTube user that gave us the right acronym here. All right, so You mentioned something that was interesting, and I just had a meeting last week with Aqua and they showed me a container that during the scan has no issue already, but then they bring in runtime, they download some type of crypto mining capability and run it on the fly, and so that's something that they were able to detect in runtime. So I guess to explain to the audience here, what do you usually end up finding when you identify the software attack surface in a static scanning side versus the runtime scanning that you could do?
Yeah, sure. So Aqua actually has a really neat project, Tracy, that they use for doing sort of runtime forensics and so on and so forth. And that's a pretty cool project. That's not where we focus on. Obviously, that those capabilities, if you could do it at scale, it becomes very important and interesting, which is what Aqua is setting out to do. And what we focus on is mostly, what we want to know is by the end of your test cycle, we have a really good idea of what your application does, and then we surface that. So we focus on the runtime throughout your test cycle. And as you can't have good DevOps if you don't have good tests. So by the end of your test cycle, you pretty much know, if not 100% of the behavior application, a very 99.9% of it if you have good tests. And then also we do propose a different model, what we call coverage scripts. I won't get into it here, where it gives you a very quick way to sort of understand the entirety of the behavior of your application. So our goal is that before you go into production and deploy into production, understand what that runtime behavior is, and what you get there um, is what's not what you can't really do at the static level. So at the static level, obviously things are interesting, especially if you're scanning your own code. Don't use this function and use the other function, and this one you're not sanitizing this input and blah blah blah, and those kinds of things are important for developers to know. But when you go beyond that into open source components, especially, then creating understanding that behavior at a static level is important, but you have to tie it into what happens at runtime when you run the workload. Now, it's possible, obviously, to build really clean, really minimal workloads. You pick a statically compiled language like Go or C or something like that, and build a minimal static executable, put it in a container that you built from scratch or with distroless or whatever. It has literally no other software but your workload. But again, as you point out, with letting your developers run at the speed of relevance, I don't want to tell my develop. We have microservices that we write in Bash because I could whip them up in 2 days. And so, I want to give that capability to my engineers to write in Python, in Bash, in Node.js, whatever is the right framework for that application to get that innovation out the door as quickly as possible. And that's sort of reflected in the industry. If you go to financial services, majority Java. If you go to a lot of these energy and so Python is becoming very prevalent in a lot of places because it's a good framework. It gets out of your way. It lets you build things that are fairly fast, and you could code them really quick and so on. So it's got a really beautiful ecosystem. So you can't just force everyone to write in C and Go. You want to give that flexibility to the user. The minute that you go there, then you get into the entire framework of how do packages get pulled in, how do they get bundled in, and those dependencies almost universally are defined statically, because it's not when I write a package and I say, hey Nick, I wrote this beautiful package and I think you could use it in your application. My package probably does 100 different things. Your application is going to use 10% of it for your application. And so when you bring in NumPy and you want to do matrix multiplication, you're going to pull in everything that NumPy does in your application, and so it's only at runtime that you can understand what your application really needed and used when it was running out of all the packages that I pulled in. And so our focus is to understanding really that part. Of course, we surface a lot of other stuff. We tell you what was the network traffic that your application. You can take that template and then build sort of OPA policies if you want to, and so on and so forth about or SEO policy and so on. And we tell you what are the system calls that you use. You could take that and build SecOn profiles. But the main focus is around telling you these are your runtime package dependencies, and you could get rid of all these other things. And here's a set of tools with a whole bunch of knobs and levers that allows you to get rid of all those stuff that you don't need. And as a result of it, you end up with, if you scan an optimized wrapper for container, what you see in there in terms of vulnerabilities is everything that sits in your execution path. And so, you got rid of 80% of your vulnerability stuff that's in your original report that it's not sitting in your execution path. And it's actually, if you optimize it, it's not even sitting in your software anymore. So you don't have to worry about it.
So, a lot of companies, right, were always complaining when I was talking about the number of CVs. Atlassian was a perfect example of this, 1,200 CVs in Confluence of Jira. And then, when I would tell them, hey, why don't you tackle down that tech debt, they would argue, well, many of the CVs are not in the code path. And so no one can get to it. Although I would debate, I'm not sure you actually know that for a fact. And with 1,200 of them, people can literally move to different things. And by the time you understand their path, it's already too late. That's probably why they've been hacked again and again this year. But if you look at the code path answer, right, why would you say people have software that's not in a code path if you're not using it, right? Why is it there?
Yeah, that's a great question. So, and something that we sort of try to answer for ourselves. We divided into like three categories. Or the issue of bloat. How does bloat end up in containers, or actually in any workload?
Right.
One part of it is the static nature of package dependencies. Like I said, you write an application that uses package A. Package A uses NumPy. NumPy does 100 different things. Your application only uses one function of NumPy.
Right.
But when you build your application, you pull in all the sub dependencies of NumPy. But you don't need it. So that's one part where bloat comes in. The other part of it is, typically in the container world, we pick an OS layer. Not everybody does, but most workloads do. OS layers come with their own set of packages, and like I said, you could build from scratch or use distro list and all that kind of stuff. But having an OS layer is nice, especially during development, because I like working in Ubuntu. I don't know, most people do. And so I have all those set of tools that allows me to sort of write my scripts really quickly and navigate, and so on and so forth. But once I'm done, how do I know what I actually need from in that OS layer? And so that's another set of source of bloat. And the third part of it is, I think you're going to like this, is that we actually put tools in our workloads, because when things go wrong in production, we want to go in and have investigation tools handy. People put GDB in their workloads. They put TCP dump in their workloads, and they end up there in production, believe it or not. And that's a really, really bad idea.
Right.
And so, you shouldn't do that. If you left it there by accident, we'll flag it, and and we remove it for you. If you left it there
Right.
on purpose, we do provide you a workflow to hot load these tools into a running container, do your
So you
investigation. When
run
you
you
go,
you add it on the runtime when you
yeah,
need
at,
it.
at runtime, we
You
hot load
inject
it.
you inject it. You inject it. Yeah.
Yes. And then the other part of it is tech debt. I mean, engineering organizations change, code becomes orphaned. You probably have a good sense of this. There's still a lot of code that's written in COBOL. Some of the programmers are no longer with us, or they're no longer programming or capable of programming, for example. But these things are still there, and so there's tech debt that over time accumulates. And that includes, by the way, config files, data files, secrets, and all that kind of stuff that get left around.
Right.
And so that's the other part of the bloat. So those are the three categories that we sort of think that bloat is coming from, and that will be identified. But there might be other ones, but those are the main ones.
Yeah. We talk about obviously container hardening a lot. When I created the Iron Bank in DoD, I guess the whole point of it was to create these base images you're talking about, right? Whether it's the OS layer, whether it's some of the most used open source capabilities, right? And we have a saying, right? Container hardening, right? But when when you talk to different people, it means different things. So what does it mean to you to harden containers?
Yeah, that's a very good question. So, yes, container hardening by and large in the industry means, or workload hardening means, short circuiting any privileged escalation paths, removing root access, removing any secrets that you've left there, and so on. So those are all important things. But going back to your Atlassian comment, that's the code is not in use. So let me tell you what our view of things is. Every piece of code that you leave in your production workload is a liability. And
Right,
it's a liability more so now that if you look at the statistics, the majority of your network will get breached at some point. And once your network got breached, what you've left around for a hacker to use is your software attack surface. It's all the
right,
software components. And what's happening now is that the popular method of sort of attacking and infiltrating deep down in the big attacks is getting to the network, just lurk around, stay under the radar, and trying to find opportunities to get deeper into the infrastructure, find secrets, find other software components, tools, or whatever that you can find to get access further down in the infrastructure while staying under the radar. That means not downloading your tools into the workload because they get picked up by systems. you know and so whatever
yeah,
tool that you left there, even if you're not using it, is a risk. Of course, it can be used as an initial attack vector, but it could be used for to move laterally, and if actually in fact it does get used to move laterally. And so
right.
don't leave them around. Take them away. Make their life difficult. Make it too expensive for them. Let them go somewhere else.
So I guess outside of blow and kind of reducing the attack surface, what other pieces do you see being part of the hardening of containers? Is there configuration settings? I mean, what else is
Yes,
there?
yes, of course. Configuration settings, removing root access,
Right.
set your removing any executables that have special privileges, or removing the bits and so on and so forth, at least surfacing them so people know, and can make informed decisions about this. But this stuff really well. The Iron Bank is basically a beautiful bank of all of these images that all of these principles have been applied to it.
We,
But
we we actually did a container hardening guide where we actually released that so people can Google it. I'll try to find the link. But if it's effectively showing all the steps, to harden containers, and obviously the attack surface is essential. But you also find all of the settings, right? So I'll put the link of the container hardening guide. It's on the DoD uh, website. But before we do that, I guess how do you end up finding a way to actually reduce, right? If people keep saying, well, we have all these static dependencies, right? All this stuff shows up magically, right, in my container. I don't know what we use, what we don't use, but how do you reduce it? How do you enable that bloat to go away? Because it seems like people are stuck with it.
yeah, so um, first, let me take it, give you a little bit of a story. So first that we saw this system work, Rajiv and I got really excited actually, and then we expanded the team and we brought other people on, and we're like, okay, this thing works incredibly well. I could just sort of have this system that very quickly I can identify what's not being used, and I have another piece of system that just pulls all these components from under them, and um, you have these smaller, you know, more secure pieces of software very quickly. Why wouldn't everyone want to use it? Outside of the DoD, and I think we get to that discussion a little bit later. When we went to the commercial space, we found that people are really early on in their journey of even containerization and so on and so forth. Kubernetes, and you know, we sit in the tech space and we talk about all these things, but you go out and talk to the rest of the industry. They're really, really early on. You have like Capital One is very advanced in the financial services, but the rest of the banks are not necessarily. They're just at the beginning of their journey. And so to go to them and say, hey, I have a system that I could just do all of this stuff and mutate your workload, and then you get something that's a lot smaller and more secure. They obviously find the idea intriguing, but they're just so far away from that we found that the way that we should present all of that stuff is in a platform, and that platform starts by saying, hey, look, I'm going to give you visibility of what you have in your infrastructure. So this is creating the SBOMs and vulnerability reports and all that kind of stuff. What we do also at that point is that we show you we have a model that predicts what's the opportunity to improve. By just scanning your workloads, we could tell you, hey, we think that there is this much unused software in your workload, and you should go ahead and profile it and see what you find. And then the next step to that is the profiling bit. So the next part of the profile platform is that, hey, let me efficiently and transparently profile this workload for you. You push it through a slightly modified deployment process that we introduced to you. And then at the end of that process, you have a full visibility of what your workload does. And now you could see which one of those packages and corresponding vulnerabilities are sitting in your execution path, which ones are not. And you could prioritize based on that. And then also you have visibility into the network traffic, into the system calls, into the file accesses and all that kind of stuff that the workload actually does. And you could make informed decisions about what you want to do with that workload. And then the third part of it, you go now to your conversation, and let's say that if you're a security team, obviously the first one, the scanning, you could operate on all by your own. The second part, maybe you get a bit of help from the DevOps team. The third part, which is optimization, your conversation with your developers changes from saying, hey, I want you to fix this vulnerability in the Nginx or see if there's an update or whatever, or remediate this, to saying that, hey, I ran your workload, and it looks like you're not using packages A and B and C and D. Do you think you really need it? Why do you need add user? Why do you need LDAP, whatever, it's not being used in the workload. And so that conversation is a code quality conversation that you can have with a developer that every developer is interested in. No developer is interested in chasing vulnerabilities in Nginx, but every developer is interested in improving their code quality. And so that conversation shifts, and now you could go to your developer and tell them, here's what I found, and here's a set of tools. You could either do it manually yourself, which, by the way, you can't a lot of times, because at the package manager level, you can't detach those static dependencies. And here's a set of tools for you to actually do it, and figure out if you want to use it or not. So that's how we tell our story today. It started by saying, hey, just go ahead and optimize everything. It's great. The world is going to be great. To saying that, hey, I know that you're going through a journey. We're going to help you with that journey. We understand where things are. We'll help you get visibility. We help you get understanding, and we help you sort of address it, and ultimately get to a point where that you can automate that process end to end.
So I guess when you look at the removal of dependencies that are tied to other dependencies, I know you've been iterating on a process to kind of proactively remove the bloat. Do you have a capability that's actually capable of like removing bloat with a human interaction, or it's always the human that's going to have to go and find a way to remove the bloat, or you have tools to remove the bloat, I guess?
No, it's fully automated now,
Yeah.
Nick. So you could literally press a button and say, and you could pick one of our presets, or you could actually have complete control over using profiles and so on and so forth, over how you want the optimization to take place. But it's completely automated. Once you have that recipe, you put it into your CI/CD pipeline, and then every build of that workload, just goes through the same thing.
Right. That's pretty cool. So obviously, when you do that, right, we talk about the security benefits, but what's the impact you've seen on performance of some of these containers when you start taking down some of that bloat?
Yeah, so they get quite a bit smaller. Let's say on average 70-80%. That translates to a lot less software that you have to download when you bring up a new cluster. So that translates to better, if you have high availability SLAs, if you're doing 4.9, for example, 4.9, you can't get to 4.9 without 3 zones. You need 3 zones to get to 4.9. And then, even at 3 zones, if your system goes down, one of your zones goes down, you need to bring up another zone. You have 60 gigabytes of images to download. That's going to take you an
Yeah.
hour. 4.9 is 50 minutes a year. So you blew your SLA at
Okay.
that point. So you do
Yeah.
4 zones. You over provision. You do 4 zones, and then so you're paying for that. It's expensive for one thing, right? And secondly, there are places where the 4 zones aren't available. So once you get hit with that downtime, which everybody does,
Right.
then you pay. You pay both in terms of reputation, and obviously customers not paying you because you breach your SLA and all that kind of stuff. So there is a performance that we're trying to quantify, and actually we're going to write a blog post about it and so on and so forth, and let people know there is performance benefits from that perspective from having smaller containers. There is no runtime performance benefit because ultimately it's the exact
Because
same code that's
yes,
running.
it wasn't being used. Yeah.
Yeah.
Right. Which is, the size of the image is obviously a very big deal, and of course you get the cyber benefit that we talked about. So there's
Yeah.
that, which is probably
Yeah.
the primary goal overall. Um, so when you take a look at all this work you guys have done, when did you found the company again? When was what year?
We were incorporated end of 2020.
2020. So
Yeah.
it's been 2 years, right?
It's been 2 years. We just had
So
a birthday. Yeah.
yeah, happy birthday. So
Thank you.
where are you now when you look at the journey and the kind of the you know light at the end of the tunnel, if there is one, or at least of your initial light? Where are you now? Do you feel like you've done 80%, 90%? What's the delta? What's missing? I guess.
So there's many ways to sort of answer that question. A typical way that people talk about it in the sort of startup world is that, hey, do you have product market fit? Where are you in your PMF journey? And it's funny to talk about product market fit as sort of like a singular point in your journey, because product market fit, by definition, is sort of an eternal thing because the market
Mm-hmm.
changes. And
Yep.
I think we have a product that it is a very complete platform. It's very usable and useful, and people are using it. But there's a lot of work to be done to sort of improve it, and we have a whole bunch of plans on how to improve it. And some of that comes from improving the core components, making the instrumentation faster, making it more transparent, all that kind of stuff. A whole bunch of bags of tricks that we apply at the engineering level to the lower level components. And then there's a whole bunch of sort of workflow UX type of stuff that we're going to
Stuff.
wrap around the entire platform to sort of automate. We want to automate the entire. When it comes to open source um, vulnerabilities, there's only a few things that you could do to remediate, and the majority of those things could be automated. And
Yep.
so that's
Yep.
that, that's what we're going to go and try to do from a UX perspective.
Yeah, that's pretty amazing. When you look at some of your offering, right, you have a lot of free offering. I was pointing to people throughout the show. There's obviously you have on rapidfort.com/free. You have a capability to optimize and harden container images, right? You have the whole community on /community with container images that are free to consume and engage there with the rest of the community. You have a full scanner on the SBOM side and the SCA scan on rapidfort.com/scan, right? So pretty much a pretty large set of offering there. How do you make money? Of course, you have enterprise services on top. What does that look like for people that want to know how to scale this stuff?
Yeah. S- uh, the So that we have the community images. Community images is a growing bank of sort of popular Docker images that within as soon as they're submitted to Docker Hub, a new version is submitted to Docker Hub. We push it through a pipeline, harden it, and put a hardened version of that image back up for the public to use. we open source all the sort of the scripts and how that's done for people to contribute to, and people could also come and contribute by asking for new images, for example, and that they might need and so on, and we put that in the pipeline. So that's one effort. By the way, that's we just started that like in the middle of this year. We only hit 50 images last week, and we haven't really marketed it yet. I think next year we're going to start letting the world know more about it, and hopefully that's something that people could use and benefit from. Then the free tier is there to sort of really introduce people to the idea that you could automate a lot of this sort of removal of unused components and as part of your CI/CD using the right set of tools. And we give a generous amount of sort of usage on the hardening component. I think it's 300 or 400 containers you could harden for free, and after that it drops to like 20, 30. The idea is really to give enough so that for smaller companies they could do it for free.
Right.
And
Right.
then if people obviously are larger companies and they getting benefits of it and so on and so forth, that we drive business from that. And and then there's a scanner, which is as an inline CI/CD scanner that's also for free forever. So you could use that as part of your CI/CD scanning workflows in your pipelines. Uh, there are a set of enterprise features on top of that. So things like registry scans and VM scans and Kubernetes scan and so on and so forth. Those don't come in the free tier at this point. So if you have those kinds of requirements, then you engage in a business deal with us. And then obviously the optimization, the profiling and optimization, the free tier only provides a certain amount of usage. So if you
Right.
if you need to push 10,000 containers a month and harden them through the
Yeah.
system, which larger companies have actually even a lot more than that, then
Right.
that's the paid tier. Yeah.
Do you is your model then paid per volume of containers or users, or is it per volume of containers that you help with? I
Yeah,
guess is it
it's a very good question, Nick. It's not based on seat licenses. It's based on volume.
volume of containers? Okay.
Yeah.
Yeah. Yeah. That makes sense. Kind of makes sense. Is your capability? Someone was asking on the chat, so I'm going to ask it now. Is it able to run on the customer premise entirely, or you need to send the containers, all the stuff to your SaaS offering, or do you have like an air gap capable thing for like a DoD customer?
Very good question. So we deployed in a number of federal environments, air gapped and obviously on-prem. So we do have an on-prem offering that nothing comes to our infrastructure. And then the SaaS is offered as multi-tenant SaaS, dedicated SaaS. There are two offerings there that you could use.
Right. Right. Interesting. Interesting.
Yeah.
So when you look at the journey, obviously you mentioned some of the UX stuff, but what are the big things, right, that you're thinking about when it comes to next meaningful, like, key differentiator features that you're thinking about for the next 2-3 years? What are you thinking about?
Yeah. And that's also so there's again core engineering sort of research type of work that we're doing. Some of that has to do around what we call fast instrumentation. So our instrumentation techniques today, they're suitable for pushing through your test pipeline, but they do have quite a bit of overhead, just because of the way that they are. So they have some amount of overhead on CPU time, but larger on clock time. One of the things that we will release early on next year is our fast instrumentation techniques. The goal is to get into under a couple of percentage points in overhead, both in clock time and CPU time. That allows us a couple of things. Hopefully, that allows us to explore with our customers running instrumented workloads in production. And then once we can run instrumented workloads in production, then that gives us capabilities, for example, of sort of delaying that profile collection all the way into production. exposed to production traffic and harden on the fly kind of a thing. So
Right.
that's one of the things that's going to come out next year. Then there's we're going to tighten up that whole sort of workflow around hot loading of tool packs, and attach sort of RBAC and authentication, all that kind of stuff to that. That's coming also next year. And then also we're looking at putting a workflow, like I mentioned earlier, around all of these things to automate the entire process. So we believe that you could get to a state of zero fixable vulnerabilities with a minimal footprint and maintain that state in almost an autonomous automated fashion, where
Right.
there's only very, very specific points that you need to get human intervention with the right processes and right tools. And we're trying to get our head around what that entire workflow looks like, and present it to our customers.
So how much of what you've been innovating on is tied to machine learning slash AI versus just normal coding, I guess? How much did ML help you get there?
Yeah. Well, we're not an AI first company or ML first company, however you say it. But
Yeah.
we do use ML because we have some experience in the field, obviously, in features where we think that it's useful.
Right.
So today, those are in two features. One of them is our ability to estimate the amount of unused components in a workload at scanning time without watching it run. And that's based on a whole bunch of data that we've collected running through and hardening a large amount of containers through our platform. The other one is, like I mentioned, around estimating the likelihood of a POC being available for a vulnerability over the course of next 90 days. But which, by the way, is very, very lopsided. So basically what we find, and this you might find this interesting, that a POC is either available when the vulnerability is reported, or then it's very unlikely for it to become available later. Some of them
Right.
do,
Right.
but then as time goes by, nobody goes and figures out a POC on a 1-year-old vulnerability. You know,
Yeah,
on
that's
top.
interesting. So
Yeah,
you're saying the timeliness is tied to the. That's interesting. I never looked at that kind of data. Yeah, that's
it's counterintuitive because you'd figure that, hey, if I'm looking at this model, as time goes by, my risk should go up. But what
right.
happens is as time goes by, your risk goes down because people are just not
I
finding that.
didn't use it. So how
Yeah.
quickly do you find CVs getting an exploit?
The, the,
Usually, I guess.
the majority, well, the POC itself, the majority of it is by far within like a week of the vulnerability. If it's not published but at the time of the vulnerability being published, then it's like within a week or so.
Right. Right.
Yeah.
Interesting. Oh, I never thought of this. That's pretty cool.
Yeah.
So obviously, when you started the company, you put a pretty heavy focus on the federal market, and I talked to a lot of entrepreneurs trying to convince them to at least, if not focus, very much invest in federal because I first with the recession coming and the disaster of the economy coming up, I think it's going to be a pretty important crutch for companies to have a revenue coming in despite the economic crisis. But but why did you decide to do it?
Um, so this is a really good story actually, because what happened was, and I don't think you know this, Nick, but so what what happened was, we had this obviously idea. The system was working. We were super excited about it, and I think Russ reached out to you over LinkedIn or something, and then he
Yep.
sent me a message. He said, he actually called me. He said, Ron, who I connected with? I'm like, who? He said, the chief software officer of the United States Air Force. I'm like, you're kidding me. And I don't know if you remember, but Jim Zemlin is a friend of the company. So he's head of the Linux Foundation. And so I asked Jim, I said, hey, do you know Nick? And he said, yeah, Nick is great. He's really well known. And Chris Anichuk, the CTO of CNCF, is also a friend of the company. And
Right.
he spoke very highly of me. I'm like, wow, that's amazing. So uh, I think it was like really early on, right after basically we incorporated, that we spoke with you, Nick, and we realized, so that was our sort of first connection into the DoD sort of landscape. And that's how we got to know about Platform One and Iron Bank and all that kind of stuff. And we're like, this stuff looks really advanced. This is pretty amazing. And the first project that we did, this first SIBR that we got, phase one that we got, was a small project to sort of, take a look at Iron Bank images. And I think you were involved. At least we got you involved in that
I
proposal
remember.
at the beginning. Was, take a look at our Mac images, let us run through 20 of those and push them through our system and see what kind of results you get. um,
Yeah.
and through that process we found out that actually the teams at the DoD, at least the teams that we interact with, they are really really advanced. In terms of what their understanding of cloud native technologies, Kubernetes, containerization, DevSecOps, vulnerability management. I mean, you guys had all of it in place. The VAT is an amazing system, and all of that kind of stuff. The whole process of Platform One is a really really advanced system. A lot more advanced than anything I've seen, actually, to be honest, in the commercial space.
I should
Um,
use you as a quote. That'll be nice. I'll use that as
no,
a
it's,
quote.
it's true. I mean, and it's a testament to honestly, to what you guys did there over the past. And I know this, you didn't wake up and this system fell into place. DoD is such a huge organization. For you to be able to manage your way through and be able to get a system like this in place is quite an accomplishment. But it's a beautiful system. And we realize that there's a lot of expertise when we talk to the engineers who are involved. And the various, Carl Fox, Rob Slaughter, all these. I mean, these guys, they all know this landscape so well. And um, and so that's where we sort of got really interested. So, these guys understand our language. They know what we're talking about. They know, I don't have to explain to them what a container is. Or what a Kubernetes is. They're ahead of us. They're saying, hey, use Istio. And then that was one of the things that one of our deployments.
I spent 6 months, telling people what a container was. They thought I was trying to ship containers to Afghanistan. Shipping containers. So that was helpful, for my life.
Yeah.
So
So that got us excited, and then we realized that, okay, that this is an organization that's trying to figure out how to build software for the next 10-15 years securely, and while staying really really fast, using open source components and so on. And they're really advancing their journey, and we don't have to educate, we don't have to handhold them and say, hey, let me scan your infrastructure and let me now profile this. And then, we don't have to do what we do in the commercial space with the
right.
DoD teams, and so that's became our focus. This is a,
So you're saying for once the DoD teams were more advanced than the commercial teams we were talking to. That's pretty cool.
oh my God, yeah, no, this is uh, I wouldn't say, I think maybe you guys from inside are more critical of it. From my perspective, we always thought, even as a kid, we talk about the United States Air Force or whatever. You know that they're super advanced. And it was really interesting to see that entire system in practice. And the DoD is a humongous organization. It's bigger than any other company. And to sort of be able to put structure around those processes and sort of navigate all the requirements and all the processes and all the going up the ranks and down the ranks and talking to the various kinds of people to get a project in place. All those processes that are in place because of good reasons, to be able to manage a really large organization, makes it really difficult to implement something like this. And to see that all in place when we got there was pretty amazing for us. And so that became our focus, because we had a group of teams that we could talk to and we could learn from, and we could get installed, so I could deploy in an air gapped environment and figure out what I have to fix in my software. Or I had to deploy with Istio and figure out what I have to fix with Istio. And we're in
Yep.
Iron Mike right now. We have to go through that whole process, and VAT and vulnerability remediation, all that kind of stuff. And I don't get that in commercial.
Right, right. And so do you feel like, you know, that direction you took, do you have regrets? I mean, do you feel like that paid off as a
Oh yeah,
business?
absolutely. Yeah, yeah, for sure. It did. It did, and a lot of it is testament to our co-founder Russ, who actually, Nick, I think, was because he
I know
really,
Russ.
because I'm like, hey Russ, the government sales motion, federal sales motion is very different than enterprise sales motion. We got to really figure out the enterprise sales motion and so on. So, and he said, look, there's a lot of opportunity here for us to improve our product and get to product market fit because these people understand all of this stuff. They can help us.
You don't have to
And
go and tell the ABCs. You can go straight to
yeah,
the end of the spectrum. Yeah.
yeah. And so once we figured out how to go through the process and the paperwork and the application and all that kind of stuff, then the rest of it was actually has been a pleasure to be a part of. It's
Yeah.
been really good.
Very nice. And of course, I see a lot of companies then using the reference, right, to their commercial customers. And I think, when you look at how many CIOs, both in telcos, banking, and healthcare reach out to me, right, saying, hey, if you were able to put Kubernetes on jets and bombers and space systems and nuclear systems, you can probably help us with my bank stuff. Obviously that applies to companies working with DoD, and using that as a reference to get to other customers too. So it's I think it's definitely a pretty wise investment. If I particularly for companies like you, I think some other companies might be depending of what they're trying to build, that might be a different story. But I think when I look at what you guys are doing, it's a no-brainer. I was talking to Chain God this morning, and I was convincing the CEO, and that's what I do now. I convince CEOs to pay attention to federal. Everybody is like, oh, I'm going to focus on commercial, but they first, I think, with the economic crisis that's coming, and it's just the beginning. I think people will realize that the government still spend the money. So that's a pretty good crutch. At very least, to covering your expenses, breaking even or whatever. So definitely worth the companies at least doing a little bit of a commitment, getting one federal public sector sales guy. Doesn't have to be massive. Doesn't have to be the sole priority, but I think it's very important to do something. So plus it's important for the nation and our
Yeah,
chance of
well, I mean,
winning against China.
I was gonna say, Nick. I mean, there's also that component of it that you just mentioned. It's if you have innovations that could be useful there, then we should really get those teams exposed to it. And that aspect of it has been rewarding for us as well. And uh, i- i- the issue for startups is that we go through rounds of valuations. That's how we raise money. Okay, and the valuation that you get from a government contract, the multiples are a lot smaller than what you get in the commercial space, because what they want to see, what the investors want to see, is that did you figure out how to sell into commercial? And they understand that that motion is very different than how to sell to government. But there is a bit of a misunderstanding, I think, from in the investment community of uh, you know you invest not just for money, you invest for impact, you invest for there's many different reasons that you invest, and the impact that you could have by working with the DoD and then using that as sort of like working in a very advanced ecosystem and using that as a springboard to bring those learnings into the commercial market
Right.
is is quite important. And we talk to our investors from that perspective. But the reason that people startups are shy, they shy or they put a lower priority is because it's primarily driven by our investors. And
And
sort
that's
of we
that's
went.
always interesting, right? Because the VCs effectively, also put a smaller multiple on the DoD. And by the way, I agree that no company should just be relying on DoD work. Usually, that's pretty toxic and work in vacuum. And I certainly agree that dual use and having commercial activity is essential. But at the same time, you talk about the importance of getting access to best technology to the warfighter and the nation. They also forget, who created the Silicon Valley and all that kind of stuff. But then there's also the fact of the reference that can be leveraged, right? By I've seen companies like Encore and many others start with DoD and really get their massive engagements from the DoD standpoint, and then grow to banks and healthcare and other companies, thanks to the references and being able to say, hey, if we can secure the DoD's container stuff, so we can help you here with your banking stuff. So I think people don't pay attention to that enough, and it's a little sad because there's also the other piece of like, hey, well, look, that you have a economic crisis, recession, and then maybe commercial can afford the nice to have product anymore, and versus the government is not going to slow down. So I think it's also short sighted from the investor standpoint in terms of the resilience of the government market, and the funding that never dries up. So that's another piece there to think about.
Yeah, yeah, I agree. Anyways, for us, it was a really good decision. We do have commercial traction, you know, but uh, but by focusing on sort of the more advanced use cases within the DoD, that helped us really improve the product very quickly, as opposed to,
Faster, yeah.
and so that was
You
that was
can go sell it at scale to the commercial people, but you're gonna have to start back with the painful. I mean, not every company, obviously. There's a lot of you mentioned Capital One and others. There's a lot of pretty innovative commercial companies nowadays, but no, you have both worlds, so that's pretty amazing.
yeah.
Um, I was gonna ask you. Obviously, you're an immigrant like me, so we understand each other a little bit. We have something a little special there going on. I'm a little bit afraid of what's going on in education nowadays. With kind of the people born here, I guess, in this country becoming more and more anti-American. It's very concerning to me, but I find a lot of people not traveling, not seeing what's going on elsewhere, and being kind of stuck in this bubble of particularly the Silicon Valley. I call the Silicon Valley the Kumbaya bubble, and I call the DoD bubble the complacency bubble. But if you if you look at what you've seen as your travel and what you've learned, what would you like to share with the group here that really kind of impacted your life?
Um, well, there's a lot about who I am that's been shaped by travels, of course. That there's the standard stuff that everybody's at the end of the day the same. Everybody has this utilitarian view
Yeah.
of what life should be, and they want to be happy and prosperous, and they want their families and the kids and their loved ones and friends to be the same, and so on and so forth. And that's sort of universal, regardless of culture, religion, race, creed, and all that kind of stuff. But uh, I think one of the things to that you pointed out is very true, in the sense that it's been quite a long time since a major war that sort of hit home here, and it's been a couple of generations, or 2 or 3 generations, and so we've gotten used to this comfort and security that sort of this country provides,
Right.
but
Complacency.
and I wouldn't say complacency. It's just maybe ignorance, if that doesn't come out as too negative.
Right.
And sort of by you know stepping outside of just America, or being an American, and so on and so forth, and Europe, and going out to some other parts of the world. And some of them are advanced. I'm not saying that they're not advanced, but to just see what are the conditions, what are those socioeconomic systems that sort of led to where those countries are now. And are we, do you like that? And do you want your future to look like that? And what are the set of priorities? And if you don't, what are the set of priorities that you want to have to focus on back home, to sort of make sure that that doesn't happen to you, over a long time, and so on. And so that you really get from going to different countries, and
Travel,
not
yeah.
just on a business trip, but spending at least a few weeks, or multiple times going
Still go
somewhere.
to Venezuela and China a little bit, maybe a couple of weeks.
Yeah, yeah, and I've been to China. It's a wonderful country, but it's the same. I mean,
It's not the people, it's the CCP, and it's the same with Venezuela, right? You look at the president, what is
Yeah,
done with the country, it's just what it is, But
yeah, and governments do turn around. And so what
right,
we have
thankfully,
here, the stuff that we have in our constitution, that sort of like empowers people to prevent that from happening so swiftly, um,
right.
uh, is very important. And sort of we lose sight of some of those facts by by you know living somewhere like the U.S. or Sweden or Norway or these countries that are just
Perfect.
prosperous and
Too
being
perfect. Too
prosperous.
easy. Too easy.
Yeah. And
Yeah.
so it's good to sort of step out and realize that, I mean, history goes in cycles and inevitably. And
Repeat itself, right? So,
yeah.
and that's the other thing. I think education, and the really doing a terrible job both on the IT side, of course, but also just history. I mean, what kids learn nowadays is just very scary to me. But anyway, we're not gonna get too political.
uh,
Uh,
I think my kids go to a French school, so
here we go.
out of all those places, so they do get quite
Mine
a lot of,
don't. Mine
and
don't. They couldn't find it. But I don't. I don't really care about French or no French. But I care about understanding the nation, understanding the story. When people start saying the flag is racist, and that I saw this school here in Virginia where there was a playground for black kids that was only for black kids. I find that to be despicable. It's just very scary when you start
mm,
doing that
yeah.
kind of stuff. Segregating kids at 4-year-old. It's just like, ready. You're
Mm.
creating the problem. You're creating racism when it should. It's not even a thing in kids of that age. They don't even think about it. But it's just sad. But anyway, so we talk about obviously economy a little bit. And I was mentioning how the government obviously can help you sustain the teams and pay for stuff while this is happening. What have you seen, I guess, as an entrepreneur yourself in the last 6 months, pretty much a year? What have you seen, in terms of challenges coming from that economy? Do you see companies maybe investing yet less, being more careful is with how to spend money? Do you see, people talking about, you know, getting rid of a piece of their team um, because of the economy? What do you see on the market?
I think from that perspective, Nick, it's a little too early to sort of understand what the impacts are. I don't see that, especially not in the security market, and especially if you have some sort of land and expand model for your business. In the sense that
Right,
you're not entering, asking for $1 million off the bat, kind of a thing, to put your system in
right,
place.
right, right,
So I don't see that yet that much, but there is of course concern that that is changing. But when it comes to cybersecurity or development, which are that's where we have one leg in cybersecurity and one leg in
Mhm.
development teams.
I
Both of
really
those,
think cyber is more impacted than development, but yeah, because people
yeah,
still see cyber as nice to have, even though it's not. But yeah, it's interesting.
it's true, but the flip side to that is that in cyber there's such a shortage of skills.
Yeah, you don't want
Um,
to lose it. Yeah,
yeah, and if people can only afford not to have that for such a small amount of time, because it's going to take him so long to actually refill that. And
yeah,
so
yeah.
so there's that part. And in terms of budgets, nobody tells you that the budget is cut, but people will tell you off the record that they've delayed it,
Right,
kind of a
right.
thing. So there's some of that that's starting
The
to
question
happen.
is how long. That's where it becomes a problem. If it's a few weeks, months, but if it's a year, that's a different
Yeah,
pain
they
point,
lied
I
it
think.
they lied it but and I haven't ran into that myself, but I've heard it. Um, so I think the main thing that I see, Nick, is that we went through over 10 years of literally pumping cash into the economy, and that was a lot of
It's
it.
like a
And
little reset.
yeah,
Yeah,
and we went to post the mortgage crisis. We gave the entire yield curve to the feds to control, and
yeah,
to be able to implement their policies and so on. So for now, I think starting in September they started pulling some $9,500 billion a month out of the economy. And
yeah.
so yes, the economy was strong and resilient, and whatever way you want to measure it. Some people say it wasn't, some people say it is, but let's say it is. But it's not a trillion, 2 trillion. I mean, because this is going to keep, 100 billion a month pulling out of the economy. At some point, something's going to buckle. And we don't know what the ramifications of that are. And that's what they're trying to sort of make sure it's a soft landing or a harsh landing. Sometimes you say that, I don't want to, death by 1,000 paper cuts. Let's just let's just have a crash land so we can
Right.
recover.
A big one. Yeah, and then you move on. Yeah, it's interesting also, when you look at the what's happening, with the VCs, right? And some valuations were just completely insane. Bloated. Talk about bloated attack surface of software. It's the same thing with bloated valuation. It's just on the napkin. No company was even trying to break even or even understand what it takes to make money, make a profit. My companies were always focused on B2B and making profit. In fact, we haven't raised a single round of funding. It's just the way I wanted to do business. But if you look at the companies now, and look, I'm not saying people shouldn't raise money, but I think there's a difference between just raising unlimited amount of money at insane valuation, and now at least from what I see, people doing their rounds now, I can tell you it's very different what I've saw last year, just in terms of their own valuation. In fact,
Yeah.
many that had deals that were pending got slashed, by up to 50% valuation cut, which is pretty
Yeah.
mind-boggling to me.
Yeah. We won't get back to that landscape for another 10 years, I think, if we ever do.
Right.
So people think that
But maybe we
this is
shouldn't.
just,
Maybe we should actually learn to make money. Maybe we should break even
I think
and
so.
make profit,
I think
right?
I think it's going back to basics a little bit, and putting
Basics of one-on-one business. You would never see valuations. I've seen these crazy, multi-billion dollar valuation, and the company is making 20 million revenue. I'm like, how do you get to 1.5 billion valuation? It's just completely mind-boggling to me. And
well,
it's so disconnected from real life.
good for them. But a lot of that is dictated by
Well,
just
it backfires, right? Because that's one round, and then you don't get to the right expect. I don't know if that's actually good, right? I think it set an immense amount of pressure and stress, right, to the founders and the company, and usually backfires, right? You get away with one round, but the next round you're gonna pay that back tenfold. I think it's actually not sustainable. It's like a Bernie Madoff kind of Ponzi scheme. You can sustain that valuation forever. So it's just not good.
well, yeah, that was reflected in sort of the difference in private and public markets, the valuation in private and public markets too. A lot of the companies after they went IPO, the valuation actually dropped. um, and it takes them a while to come back. But nevertheless, you do see some good companies coming out of that system. If that,
Sure, yeah,
um,
yeah, for sure.
I
Not
don't
the
think that's
entire
sustainable.
system is rotten. There is some hope left. Yeah, no doubt.
Yeah.
Some good companies. I lost a lot of money in the stock market recently, but that's okay. That was something that was bound to happen. I made a lot of money too, so I guess it's what happens. But so obviously, my last question to you, right, is what keeps you up at night when you look at what's going on both in the world and in the company and with your life. What keeps you up at night?
Um, so, well, overall, I'm a very optimistic person, Nick. So,
That's
I
good.
think everything is going to be fine. Let me
Good.
let you know.
As long as we
But
do something about it, because it's not gonna be magical. But I agree. Yeah, it's gonna be fine as long as we wake up. If we
I
keep
mean,
sleeping, I don't know.
the world that we live in and all that kind of stuff, those kinds of things. Obviously, there's a lot to be concerned about, but overall, I'm very optimistic. I think, over the long run, everything will just keep moving
We're
forward.
gonna
And
win. We're gonna win.
yeah. Just in terms of the company, I think what keeps me up at night is, well, we got to figure out how to scale this thing. And the question is that, if you look at the macro situation in terms of, the economy and all that kind of stuff, like I said, we've never been in this set of conditions before to make a historical reference, to sort of even be able to want to predict what happens as we go through this process of quantitative tightening and everything that's happening in the world, and Russia and all that kind of stuff. So um, I think there is a lot of uncertainty in what the market how the market is going to react to the macro environment, both geopolitical and economical, of course, and how does that translate to companies like us, where will we be able to get to a point where we could sort of make enough money or raise enough money to sustain through whatever that period is, if it's 2 years or 3 years or 1 year or 4 years, and get our get the stuff that we've worked on and we really think that is useful for people into the hands of more people and so on. So that's sort of that's probably the most important thing at the high level in my mind. Obviously, I worry about, did we fix this bug and what's my performance here? There's all these kind of,
Yeah, sure.
and but those come and go by the end of the week. But the one that's sort of a consistent theme these days for me is, can we sort of carve out a path where it lets us navigate with lower risk and higher certainty over an uncertain economic period at this
Yeah.
point. And so we don't know that. We try to hedge our bets. We try to sort of be very careful in how we spend money. We try to be very careful in how we raise money and all that kind of stuff. So we'll see. Hopefully we're making all the right moves.
It's not easy, right? And it's okay to fail a little bit and learn fast, but don't fail too much. Otherwise, obviously, that's a problem. But
Yeah.
it's part of the learning. It's okay.
So Nick, I have a question for you if you have time. I don't. Do we have time?
Yeah, go for it.
So how did you end up doing this whole thing at the Air Force, the Platform One, Iron Bank, all that kind of stuff? What's your story behind it?
Well, first I got into the job by having I guess the leadership at OSD reach out to me and talk about DevSecOps and cyber and zero trust and kind of trying to see how do we bring it into the department. And then we created the DevSecOps initiative and we started to get some momentum. Yeah, I was fighting a lot, all the legacy stuff and also the Cloud Foundry, massive amount of money. The Air Force was spending 100 million a year on that, which was about to die, and I was the only one telling people to stop using it before it was going to be too late. And hundreds of teams was talking about jumping on that and spending more money with Pivotal until I was like, that's going to be a problem. And we need to be on Kubernetes, we need to be using Lego block containers, reusable, looking at what SpaceX has done and comparing it to other companies that we work with. So it was a pretty big 1 year kind of learning curve. And then we had so much success that the Air Force, Dr. Roper at the time, said, hey, we need a new office for this, let's create the chief software office. So I became the first chief software officer in DoD. And so then for me it was pretty obvious that looking at the reinventing the wheel and all the work being done in vacuums and the lack of talent, and that we needed an enterprise service that would be flexible enough and nimble, just like companies like I've done it 12 times in my life before the department. And so for me it was just building a startup inside of the building. And so we created Platform One, and tackling some of the key problems were pretty common sense. Iron Bank doing hardened containers, so we can centrally accredit Lego blocks and reuse them across and all the DoD teams, open source and commercial products. Bringing the Kubernetes stack and hardening it and bringing kind of a push button instantiation, full GitOps of Kubernetes and the service mesh to bring zero trust. My big focus was always both the software and cyber, and that's what's pretty unique with my hats is having kind of that dual expertise in software as a developer and cyber, and trying to find the balance between both, which is always effectively shooting at each other. So finding the balance of cyber and software is probably the reason why DevSecOps can be actually so efficient. And so over time we had no money, no team, and we started to build some pretty good use case and showing return on investment. We save 100 years of time in 1 year moving to DevSecOps, and with 27 DoD programs. And so when we started to get that momentum, then we were off the rail and started talking to companies a lot. I was always pretty accessible. We had the Ask Me Anything events, people live taking 80 questions every 2 hours, 2 hours, 80 questions live from companies. And really, we brought, I think, 750 companies that had never done business with DoD into the department through CBER and other mechanisms, get them accredited. So kind of removing the bottlenecks and the impediments to doing business with DoD. So yeah, it's been fun. I kind of miss it. It's a special. It's kind of tough, right? Because you leave that kind of mission, and there's nothing as important, right? It's like going back to the mobile stuff or whatever. Pick your poison, right? There's nothing like the work we do in the department. So it's pretty tough because you get really hooked to the mission. So
Yeah.
So with that, we always give the guest the last word. So get ready for that in a second. I'm just gonna tell everybody thank you first for joining us. It was a great session. This is the last episode of the year, so I'm gonna wish you happy holidays and happy New Year. We'll see you on the next episode coming January 10th. At 1 p.m. Eastern with Robbie Ann. And it's going to be a very interesting episode, but I'm not going to tell you too much. We're going to announce it beginning of January. So we'll see you January 10th, 1 p.m. Eastern. We're going to be posting some videos this week, so you'll see that coming. But in the meantime, let's go to you for the last words.
I hadn't prepared anything, but let me tell you, I really appreciate you having me on the show, Nick, and also for you, for being part of our journey early on and giving us the confidence to move forward. I think that a lot of the stuff that you did and put together at the DoD has been amazing, and as to be part of that sort of journey and an ecosystem throughout the time. But by the way, just so people know, it's not like you and I know each other that much. This is probably the second time or third time that I'm seeing you. But nevertheless, I want to give you kudos for all of that, and thank you, and thank you for having me on the show. I wish everyone a very Merry Christmas and a happy holiday season, and a great 2023 ahead. And despite all the economic situation and all the things that people are worried about, I think we'll have a great year.
There we go. With that, I wanted to thank everybody. See you next year. And please keep up the good work so our kids have a fighting chance at winning against China 20 years from now. Stay safe, everybody. See you next year.
Bye.